Welcome to derivatives of common functions. So again, we've seen now that we can take the derivative of polynomials very quickly, but we would like to be able to take derivatives of other functions as well. So we've now seen how to take the derivative of a polynomial quickly. But what about other functions? So some common functions, we have our basic trig functions. So we have a sine of x, cosine of x, our basic exponential e to the x, and then let's also go ahead and take a look at our natural log. So we are going to take the derivative of each of these. So the derivative of sine of x winds up simply being cosine of x. The derivative of cosine x, on the other hand, winds up being negative sine of x. The derivative of e to the x, e to the x is a very special function. The derivative of e to the x is in fact simply e to the x. And then last up is our natural log of x. The derivative of the natural log of x winds up simply being 1 over x. So here we have 4 functions that are standard functions that we see fairly often in a variety of applications. And now we can quickly take the derivatives instead of having to use the limit definition and then trying to take the limit with some of these more complicated functions involved. So some examples. Let's go ahead and find the derivative of f of x equals 5 sine of x minus 3 cosine x. So using our derivative rules, we know that we can split this so that we are taking the derivative of 5 sine x and then subtracting the derivative of 3 cosine x. From here, we could go ahead and pull out our scalars. So this is 5 times the derivative of sine of x minus 3 times the derivative of cosine x. And then this becomes 5 cosine of x. Then we are subtracting 3 times negative sine of x, or simply 5 cosine of x plus 3 sine of x. So now we can find the derivative involving cosine and sine much faster. And let's go ahead and do one more example. Let's find the derivative of g of x equals 3e to the x. So g prime of x would be the derivative of 3e to the x. Again, we can go ahead and pull out the scalar multiple. This becomes 3 times the derivative of e to the x. And the derivative of e to the x is just e to the x. So we actually get out, once again, 3e to the x. So the exponential function, we essentially just keep getting the same derivative over